So hello and welcome to my first application using multi-agent workflows plus RAG. And today we will be building this architecture that uses the hierarchical agent teams design. So as we have to start from somewhere, we will be starting from the left side of this architecture. Let's go with the task number one, which is the simple LangGraph RAG. As I have implemented my custom solution to this LangGraph RAG, let's jump straight into it. So here we have it, the RAG graph pipeline that dynamically fetches papers using archive tool. So here we define our state, as always, the object that is going to keep track of the current state at its node. Then we go with the R of retrieval. We load the documents from the directory. Then we define our length function that is going to allow us to measure the chunk sizes by tokens instead of characters. We instantiate our recursive character text splitter. Next, we split the documents. We instantiate our embedding model. And then we instantiate the vector store from those documents. And this vector store is going to be placed in memory. Next, we define our retriever. We make our vector store as a retriever. And then we can just jump in with the first node, which is going to be retrieved. And what does this node? Well, it first instantiates the runnable to fetch dynamically those documents. And we can invoke this runnable on the question and get a context. And then we instantiate our second runnable that is going to get the context from the documents in the vector store. We combine both contexts and we return this combined context that is going to be placed in the augmented part in the prompt template. So here we instantiate our human template and we create a chat prompt with the role human and the content is going to be the human template. Next, we go to the generate part, we instantiate the model, we instantiate our node for generation, and then we just can create the graph. So we instantiate our blank template, we add the sequence of nodes that we have just created, and we make an edge from start to retrieve, and we compile the graph. Now we can use our graph in the question, how does the average person use AI? And we can see from the response that we have successfully retrieved dynamically papers from archive. So next, let's go with the task number two, helper function for agent graphs. And what we basically do is create a function that will help us create agent nodes in an easier way. Then we have like the function create agent that basically takes the brain, the LLM, the tools and the personality, the system prompt. And what it does is to create a working agent by using the agent executor function. Then we have our supervisor helper function that is basically a router. It takes some options, the finish and the team members, and what it returns is a JSON dictionary with the key next and the agent that is going to be performing next. So let's go with task number three, our research team. Let's provide our team with some tools, like for example, a Tabili tool to browse the internet, a retrieve information tool that simply returns the response from our RAG pipeline, and then let's create a research team state that has this useful keyword to know which agent is going to be performing next. We create the brain from our research team that is going to be GPT-4o, and what is this important? Because we will be doing complex reasoning and decision making, and for that we need a powerful LLM. Next, we create with the functions we have defined above the agents, the search agent and the research agent that is going to have the brain, the LLM, the tools, and a personality. And next, we can create our supervisor agent with the function we created, create team supervisor, that is going to route between search and the research agent that is called how people use AI retriever. Next, we can create the graph. And what is interesting is that each agent is going to be reporting to the research supervisor. We set the entry point to be this research supervisor. We compile our graph, and now we can execute the graph. But first, we need to create a bridge between the higher level graph, our boss, our top level supervisor. And for that, we create this enter research chain and we just can create the chain for our research team. Now we can just execute the chain, and we can see here what is happening, that the research supervisor receives the query and decides that next is going to be performing how people use AI retriever that reports to the supervisor, and we finish the tasks. So let's go with question two. How could you make sure your agent uses specific tools you wish it to use? And are there any ways to completely set a flow through those tools? So yes, we can use tool-specific agents. We instantiate our agents and then in the routing function, depending on the state, we route to one agent or to other agent, or we can just create our agents and invoke them in a specific order. And then there is also a really useful parameter called tool choice that allows us to force a specific tool, or at least to force the agent to use one tool. So next, let's start with the task number four, our document writing team. So as previously, we load the documents, we instantiate our vector data store, we instantiate our vector data store as a retriever, and then the interesting part about our document team is the tools it's going to use. Like these tools here are just Python IO operations wrapped as launching tools for agents to use. They allow us to create an outline, to read documents, to write documents, to reference previous responses, and to edit documents. Next, we create our document writing team state that has a new parameter current files to keep track of precisely which are the current files. And then we create a prelude function. And what does this function do? It's a function that gives our agent awareness of their file workspace, which is going to be really useful. Next, the brain for this writing team that is going to be GPT-4o, obviously because we need a reasoning model. And next, we just create our agents. Each agent is going to have the brain, the tools it can use, and the personality. We create also the supervisor team, and we just can create the graph that, as always, each agent team is going to be reporting to the supervisor. We create the graph. Here we can see the anonymous lambda function that uses the output of the authoring supervisor, that we must remember that it outputs a JSON with the next agent that is going to be followed. We compile our graph, we display it, and as always, we must create an interface between our top supervisor and the research teams. So we here just can invoke our graph and see what is happening. So let's start with, lastly, with our Task number 5, the meta supervisor and the full graph. And as always, this is pretty straightforward. We just create the brain, which is our reasoning model, the supervisor, and then we create the state. And these two functions that will allow us to keep the context pristine. We only pass the most recent message from the parent graph to the subgraph, and we only extract the most recent message from the subgraph to include in the state of the parent graph. And then we can create the last graph that we can notice that each node is an entire LangGraph agent, which is awesome. And then we create the edges as always with a lambda function for routing. We set the entry point to be this meta supervisor, and we compile a graph. We invoke our graph in streaming mode, and here we have our custom report for Ines. Thank you so much for having been here with me, and see you next time. Bye bye.